In-depth exploration of Mars, the red planet. We'll delve into Mars's physical characteristics, including its size, orbit, and seasons, details of its two moons, Phobos and Deimos, and the planet's thin atmosphere, responsible for extreme weather phenomena. We'll also explore Mars's varied terrain, from the towering Olympus Mons to the vast Valles Marineris, and investigate the presence of water and its implications for the existence of life. It is visible to the naked eye, distinguishing itself from the other celestial bodies by its specific color, which is why we call it the red planet. The first written records about Mars come from ancient Mesopotamia, where it was associated with their god of war. In the Far East, it was called the fire star, and in modern times bears the name of the Roman god Mars. Mars is the outermost terrestrial planet in the solar system. Its diameter is half that of Earth's, measuring just 6,780 kilometers, and its surface area is comparable to that of our 7 continents. Due to the planet's small volume and lower density, gravity is just over 1/3 that of Earth and almost the same as that of Mercury. Mars stands at an average distance of 230 million kilometers from the Sun, equal to 1.5 astronomical units. It has an elliptical orbit strongly influenced by Jupiter and the other outer planets. Mars's orbital period equals 687 Earth days, but a Martian day is only about 39 minutes longer than Earth's. The axial tilt of the planet, also known as obliquity, is very close to that of Earth, at around 25 degrees. That results in the existence of different seasons throughout the Martian year. The elliptical orbit of the planet leads to the different duration of each season. In the northern hemisphere, spring is the longest, and autumn is the shortest. In the southern hemisphere, the opposite is true. Winter and summer also differ both in duration and climatic conditions. North of the equator, seasons are more temperate, but in the southern hemisphere, there are significant temperature fluctuations. That can be explained by the orbital motion of Mars. At the closest point of its orbit, known as perihelion, the planet stands at a distance of 206 million kilometers from the Sun, and the farthest point, called aphelion, is much farther away, at nearly 250 million kilometers. Mars has 2 natural satellites that are significantly smaller than our Moon. They are named Phobos and Deimos, after the sons of the ancient Greek god of war, Ares. Both bodies are probably gravitationally captured and originate from the asteroid belt between Mars and Jupiter. Phobos is the larger and closer satellite, orbiting approximately 6,000 kilometers from the planet. It has an average diameter of about 22 kilometers, and its surface is highly uneven and cratered. Phobos rises in the west and sets in the east because its orbital period is shorter than the rotation period of Mars. The tidal forces of the planet are causing a decrease in Phobos's orbital radius, and it is expected to either be destroyed or crash into Mars in about 50 million years. Deimos is almost half the size of Phobos and has an average diameter of 12 kilometers. Its shape is irregular, and a layer of fine dust covers the surface, giving it a smoother appearance with fewer visible craters. The orbital period of Deimos is more than twice that of Phobos, and over time it is moving away from the planet. Due to its slow orbital motion, Deimos rises in the east and sets in the west. Both moons orbit in Mars's equatorial plane, which is unusual for gravitationally captured bodies. Therefore, there is another hypothesis that explains their formation through a collision between Mars and another massive object. It's plausible that the 2 satellites formed from debris ejected into orbit around the planet, but currently, there is not enough data to support that assumption. Mars has a thin atmosphere, with surface pressure over 100 times lower than Earth's. It contains 95% carbon dioxide, 2.6% nitrogen, 1.9% argon, and small amounts of oxygen and carbon monoxide. Traces of methane have also been found, probably produced by geological processes. The color of the atmosphere has a reddish hue, due to suspended in the air dust particles, rich in iron oxide. They are carried by the planet's surface winds, with a speed of several kilometers per hour. As Mars approaches perihelion, we observe an increased temperature exchange between the two hemispheres, generating powerful winds. They reach speeds over 160 kilometers per hour and are responsible for giant dust storms that sometimes envelop the entire planet. The surface temperature on Mars ranges from -150 degrees Celsius in the polar regions to 20 degrees Celsius in the equatorial zone. Temperature decreases sharply with altitude as a result of the low atmospheric density. For billions of years, Mars has been undergoing a process of atmospheric loss because the planet lacks a magnetic field and thus has no protection from the solar wind. On the side facing away from the Sun, a tail forms, consisting of ionized hydrogen, oxygen, and carbon, as those gases escape into space. Magnetized rocks in the Martian crust indicate that about 4 billion years ago, the planet had a magnetic field. It disappeared several hundred million years later following the cooling of the planetary core. The absence of a magnetic field and an ozone layer renders the surface radiation levels 40 to 50 times higher than on Earth. In addition to a magnetic field, Mars may have also possessed tectonic plates in its distant past. Evidence supporting this theory comes from the variation in the polarity of magnetized regions in the crust, which form distinct stripes. Similar stripes exist in Earth's oceans. They are the aftermath of the drifting of tectonic plates, creating magma-filled rifts. Periodic reversal of the planet's magnetic poles is responsible for the different magnetic polarity of those volcanic rocks. The surface of Mars is made mainly of basaltic rocks containing silicon, oxygen, and various metals. A layer of fine dust, rich in iron oxide, covers the surface, which gives the planet its characteristic color. Compared to Earth, Mars has a higher content of chlorine, phosphorus, and sulfur, due to the farther distance from the Sun. These elements have lower boiling points and were pushed by our star into more distant regions of the solar system during the initial stages of its formation. Early telescope observations have revealed two types of surfaces with different reflectivity. Brighter areas were historically called continents, and darker regions were named seas. Today, we know that this visual perception can be attributed to the variations in the topography and the concentration of dust particles. The terrain of Mars differs significantly in the two hemispheres. North of the equator, the average elevation is several kilometers lower. The southern hemisphere is dominated by high plateaus, contrasting with the plains of the northern hemisphere, shaped by ancient lava flows. One hypothesis suggests those drastic differences arose from geological activity billions of years ago. The process responsible for the variation in the Martian crust is a non-uniform convection in the mantle. Another possible explanation is the impact of a celestial body that formed an enormous crater near the North Pole. That area is known as the Borealis Basin, covering nearly 40% of the planet's surface. The scientific community is not unanimous about whether that depression is the result of an impact. If this assumption turns out to be true, the Borealis Basin will be declared the largest crater in the solar system, with a diameter of almost 10,000 kilometers. Thanks to the lack of recent geological activity, over 43,000 craters larger than 5 kilometers are visible on the Martian surface, along with hundreds of thousands of smaller ones. Most craters are found in the old crust of the southern hemisphere because lava flows have obliterated a vast number of meteor impacts in the northern plains. Many craters formed billions of years ago, but some are more recent. Despite the planet's small size, its proximity to the asteroid belt increases the likelihood of collisions with other bodies, including short-period comets. One of the most prominent features in the topography of Mars lies in the equatorial region, a system of canyons called Valles Marineris, which is over 4,000 kilometers long, 200 kilometers wide, and up to 7 kilometers deep. That geological formation between the two hemispheres is most probably owed to the specific evolution of the Martian crust. If the planet once had two massive tectonic plates, as some scientists suggest, then Valles Marineris marks their boundary. Mars is also home to the largest volcano on a planet in the solar system. Named Olympus Mons, that volcano towers 25 kilometers above the surface, making it 3 times taller than Mount Everest. Its base spans over 600 kilometers in diameter, and the crater at its summit is 80 kilometers wide. Olympus Mons has reached this colossal size thanks to the planet's weak gravity. A likely cause for its formation is an active region in the mantle located beneath a relatively thin planetary crust. The absence of tectonic plates has led to volcanic eruptions occurring at the same place over a very long period. Like the other volcanoes on the planet, Olympus Mons has not been active for millions of years. The surface of Mars shows signs of liquid water in its distant past. Networks of ancient river valleys, deltas, and lakebeds have been found, along with rocks and minerals that can only form in an aquatic environment. Some 3.5 billion years ago, Mars had a denser atmosphere and warmer surface temperatures, allowing the existence of liquid water. During that period, the planet had an ocean that covered a third of its surface. Over time, most of the water evaporated and was carried into space by the ongoing process of atmospheric escape. Nowadays, the low atmospheric pressure on Mars prevents the existence of liquid water on the surface. However, the planet's polar regions have permanent ice caps. Those ice caps contain water ice covered by solid carbon dioxide, also known as dry ice. During the warmer seasons, much of the carbon dioxide sublimates into a gas and returns to the atmosphere, and during winter, it accumulates again. The total estimated amount of water on Mars is enough to cover the entire planet, with an ocean 35 meters deep. Water is a crucial factor for the emergence and survival of living organisms.